take a look at solving an equation in quadratic form. And we're going to be solving the equation 2 cosine squared theta minus cosine theta minus 1 equals 0. And we're going to take a look at an angle measure on the interval from 0 to 2 pi. Now remember, in the past you've worked with quadratic equations or quadratics, and you had to go ahead and factor them. So in the past, your quadratic equation probably looked something similar to this. Right? 2x squared minus x minus 1 equals 0. And you would have broken this up into two sets of parentheses. Looking at your 2x squared, you knew one of these had to be a 2x and the other one had to be an x. Both of my slots here would be a 1 in each of those. And then we'd have to go worry about placing our signs, knowing that we needed to have a negative sign here in the middle. So we would have ended up with x minus 1 as one of our factors, and 2x plus 1 as a second factor. You can always double check that by using your distributive property to make sure that you end up with that same quadratic that you started with. The same idea is going to happen when you're working with trig equations, only this time instead of an x, you have a trig function, in this case cosine of theta. Right? But it's going to be factored the exact same way. My beginning piece here is 2 cosine squared theta, so I know in one of my sets of parentheses I'm going to have 2 cosine theta and cosine theta in the second set. I'm going to have a 1 as the number in the back end of each set of those parentheses. And now I can go ahead and place my signs inside my parentheses. I still need to make sure I have a negative cosine of theta when I go to distribute. And now, just like before, if you were over here on this right-hand side and you were solving this for x, you would have taken each set of these parentheses and you would have set them equal to 0 so that you could solve them for x. You can do the same thing over here working with your trig function. Take each set of parentheses, and we're going to go ahead and set it equal to 0. So let's go ahead and work with this one on the right-hand side. We have cosine of theta minus 1 equals 0. Let's go ahead and add 1 to both sides. We're going to get cosine of theta equals 1. Now remember, we're solving for theta, so let's go ahead and do inverse cosine on both sides. And this is going to give us an angle measure. Let's go in degrees first. Our theta value here is going to be 0 degrees, which would also be 0 radians. Let's go ahead and take a look at our second equation that we had here. We can go ahead and subtract 1 from both sides. That's going to give us 2 cosine theta equals a negative 1. And we can go ahead and divide both sides by 2. And we're going to get cosine of theta equals negative 1/2. Now keep in mind, when you're looking at this piece, your cosine value here is negative, and so when you're looking at your quadrants, your cosine value would be positive in quadrants 1 and quadrants 4. So the fact that we have a negative value here means we're going to be looking for 2 answers. One of them should be in quadrant 2, and the other one should be in quadrant 3. Alright, so let's go ahead and take inverse cosine of both sides. And let's go ahead and work in degrees first. This is going to give us an angle measure of 120 degrees. Which is the angle measure we were looking for in quadrant 2. Keep in mind, if we use a reference angle here, we are 60 degrees away from our x-axis. So if we know we also need an angle measure in quadrant 3, we can come down 60 degrees into quadrant 3. And that's going to give us an angle measure of 240 degrees. Alright, so we have a total of 3 answers for this question. We have an angle measure here of 0 degrees. We have an angle measure here of 120 degrees. And an angle measure of 240 degrees. Let's go ahead and get each of these values converted to radians. So the 120 degree angle measures can be the same thing as 2 pi over 3, and 240 degrees is going to be the same thing as 4 pi over 3. And then obviously if we're looking at our angle measure of 0 degrees, this would be the same thing as 0 radians.